GrainyTails video number 1 for GrainyTails today. Oh, hang on. Grainy dog. Today we're going to be going over the CNC machine that I built. So I built a custom-made CNC. So I spec'd out everything on this thing. It's been basically handmade. All the rails, all the motor system, all that stuff like that. So the electronics control box, everything. So let me give you the short but informative video. If you guys have questions or anything like that, you can always leave a message, contact us through any of the channels on the website. But what we have here is a old Apple machine, old MacBook Pro that I outfitted with Windows because I don't really like Mac. So this guy is USB controlling a custom electronics board. All these connectors, you know, I got them off of eBay. They're pretty cheap. I mean, you can get them for probably like, these guys I think were like $3 or $4. USB pass-through was probably like $5. So we're not talking super expensive gear. Custom fan here, which plugs into AC current. I like that because it's hard to find DC voltage on these small controlling boards that has enough power to run a fan to cool it. So this is a power supply which actually drives the motors. The motors need a little bit more juice, so you need at least a 3 amp capable motor, maybe even more depending on the weight of your gantry, depending on how big your motors are. The variable frequency drive, something I highly recommend because I had one of those little 480 watt, just basically tiny spindles, and they really don't have enough power to drive anything significant as far as cutting goes. I mean, you might get 30. You probably don't even get 25 thousandths of an inch of cut before you really get some serious, chatter, because the motor just can't keep up with the output necessary for that. So what we have here is a variable frequency drive, which is going to put out 208 volts and at least 15 amps. And we have a 2.2 kilowatt spindle, 25,000 RPMs. So whatever the load is, the shear load, this thing can really cut through it. It's got a lot of juice to it. I just went through a major overhaul. I had a previous rail system over here, and I had these little linear bearings. I would not recommend using any of those things for the actual attachment to your spindle head, because your spindle, as you start cutting and moving around, it's going to be a lot of pressure, and they don't have enough rigidity to withstand it. So your cuts are going to not look that good unless you do something like really slow down the feed or really take a light cuts, and then that's going to increase the amount of time it takes for you to actually get through any of your projects. So I took a 8-inch long 6x6 inch 3/8 thick piece of solid steel, and I lightweighted a bunch of it. I had to use a plasma cutter to do that, so I have access to a lot of these pieces of equipment based on what I do. I'm an engineer by trade, so I have access to a mill, a lathe, all these pieces of equipment that can really put a precise hole or metal cutting fabrication technique on. So if you have access to that, I highly recommend you go this route, because some of the stuff you buy offline, I don't know if you've ever tested it, but they really don't have the stiffness and the rigidity for you to do anything substantive. And most people think they can get away with just buying a little tiny machine and using that to cut some stuff, and it'll do it as long as you have the patience to wait the amount of time it takes to go through, I don't know, let's say if you do 10 thousandths of an inch cut, which is probably the most a lot of those little things can handle, and you have to cut something an 1/8 inch thick, I mean, you're talking 12 and a half passes for you to even get there, right? That's a lot of time, especially when your feed rate's something like, a millimeter per minute or 2 millimeters a minute, because you're using a very small bit. Because if your spindle head's that small, chances are you probably got nothing bigger than an 1/8 inch in, ER11 style collet. That being said, let's have a look at this thing. So I have all steel rails. They're pretty rigid, 303 grade, the good stuff, bought from McMaster Car. This is the lower grade stuff. It's just the base, and you can see that I left this stuff a little bit loose for now because I'm still dialing in the parallelism of my two X rails. And one of the easier ways to get close is to leave these things loose, travel from one side of the stage to the other, go back and forth, and let the stage kind of get close, and then you can start to tighten it up a little bit but leave it loose, and you're gonna have to bump up from there to a different method of dialing it in. The closer you get it, the better you can get it. Quick little cheating trick would be to take a set of calipers, and you can open these guys up and clamp them to something, and then use a shorter distance to actually get your thousandths of an inch accuracy, because the calipers themselves, they got some really, really good precision level accuracy. It's a rack and pinion system, sort of the same way this is. Now, in order for this rack and pinion system to actually be accurate, you see this rack right here, and I got it hard mounted into this plate. This is why I had to do this on the mill and measure this really precisely, because if this hole and this hole aren't at the right necessary width to bite this rail and keep constant pressure, it's going to introduce another source of error. If the relationship of these to the rail to this hole holding the shaft, which holds the pinion, goes into the rack, if you can imagine teeth going in here, the further up I am, the more play there's going to be when switching directions. And you're also going to have a lot of problems if you have this type of style and you go from one rail to the other rail over here. If the distance from the top of this rail to this surface is different on this size, you're going to get motors that require a different number of steps to go the same distance. That is not going to work on a mirrored system where you're controlling two motors in the opposite direction with the same controller. So you're going to need an independent controller to control a different axis. It's going to be a nightmare. You're going to end up spending tons of money, so don't do it. So keep that in mind whenever you buy something offline that's a prefab kit. Speaking from a position of experience of cutting metal for many years and actually designing a lot of systems of much higher complexity, you will never get anything of the accuracy level necessary, especially over a 4-foot throw, to not introduce, a good amount of error. No matter how precise your system is, and I mean the most precise, even a set of case hardened steel weighs on a mill that's like a Bridgeport or some highly expensive piece of equipment is still going to give you about, depending on how good it is, it can vary from a few thousandths to 10, 20 thousandths of an inch over however big the throw is. If it's a big machine, you can probably expect you might get 10 thousandths of an inch inaccuracy from one side to the other. So that being said, this is the system. Now, I did not use this rail system right here for the Y gantry. One, this is solid steel. It's pretty heavy. This is also steel, also heavy. So this guy right here was about 17 pounds when I first got him. After I plasma cut out a couple of truss designs, I was able to shave off about 6.5 pounds. Add up this plate, which is also steel, you are looking at about a 25 pound Y gantry system. So it's a pretty significant load, especially when you start adding cutting forces. Add this guy in there and we're probably in the ballpark of about 30. So in order to carry that load, I had to get grease fit high force linear carriages that have ball bearings inside them. A lot of people run these things dry. I don't recommend running them dry. They're going to seize, they're going to wear even faster than they would. Even case hardened cold rolled steel will wear over time, especially when you want this thing to last. A lot of these greases have solvents in them and things that will keep the rail operating smoothly, keep it from corroding, keep it from binding. So that is something to definitely keep under consideration, because as the loads increase, those balls actually deform. And don't think that just because it's hardened steel, it is imperceptible to sources of error. Like everything has problems with it. So if I run my homing parameter, my stage is going to go up, and I'm going to come back up here nice and slow. So the first pass is it's going to seek out this switch. When it hits it, it's going to back off because I've programmed that in there to pull off a certain distance. Once it touches that, I put an RC circuit in line with this switch to eliminate electromagnetic interference and false readings.